to Tide. So as you can see here in front of me, I have my Nav and Radar app Notes. Inside the app, you can press Notes and then you can download them and you can view them at the same time. I'll just be going through the syllabus, understand basic causes of tides, differentiate between spring and neap tides, understands the relationship between chart datum, lowest astronomical tide, mean high water springs, understand information contained in Admiralty tide tables, calculate height and range of tides at standard ports, height and tides at secondary European ports, calculates height of tide for a given time, basically secondary ports, states the difference in calculation of Pacific tides including secondary ports. So first of all, what causes tide? Well, it's the gravitational pull between the sun, the moon and the earth. That's it, isn't it? Good. I've got plenty of extra information inside the notes, but tides can either help or hinder a mariner. If you're using it to your advantage to get from A to B to the pub quicker, or to get over a certain depth, or to get inside a harbour, inside the Meds, inside the Caribbean, well, that much tide. Those of you who have done yacht masters in the UK or in tidal areas will know all about tide. Spring and neap tides. Spring tides is a bigger range, so the higher highs and lower lows. Yeah, so springs is when the sun and the moon are opposite each other. So you've got maximum gravitational pull. Neaps is when they're 90 degrees out to each other. You're on YouTube, just type in causes of tides and you'll find a plethora of videos. One of the questions which has come up is, if that represents springs, what does neaps look like? Neaps looks like that, doesn't it? So that would be spring tides, a larger range, whereas neaps is a smaller range. Higher lows, lower highs is neaps, springs, higher highs, lower lows. Understand the relationship between chart datum, lowest astronomical tide, mean high water springs. There are some fantastic explanations inside MP 5011. That is effectively what you would need to know. That's reproduced inside the notes. I'm not going to spend too long on this because in the exam, in section A, there's always a secondary port question. I've never seen a theory question on tide. Now there's no reason why there shouldn't be, so I would suggest having a quick read through. If there were a question, these notes match everything that comes up inside that the syllabus on it. You could be asked about tidal stream atlases, so you've got tidal stream atlas. I'm sure you've all seen one of those when you did your yacht master. Or more likely is an Admiralty tide table. So Admiralty tide tables, well, what's in them? Well, you have daily pages for all the primary ports in the area. So in this case, volume 1 is the UK. And you have all the primary ports and all the primary port tidal curve diagrams. And then at the back, you have all the secondary ports and all the differences. Now that is what we're going to cover today. You ought to be aware at the front of this book, they have instructions on how to do it. They have a pro forma here. And they show you how to interpolate and extrapolate. They tell you how to do everything they expect you to do in this exam. So much so that these are the extracts that you will probably have in your exam. Yeah, you'll be using these in your Nav and Radar. and they reproduce the instructions. So personally, and they are identical. They really are. They talk about what to do, how to use it, what they're expecting. So I would suggest that when you're doing this, that you use the instructions that they've given you and the pro forma that they've provided. At the back of the Admiralty tide tables, they have a blank pro forma and then the instructions for secondary ports. These instructions is how I'm going to teach it to you in this video. Okay? Admiralty tide tables. That is what you will have in your exam. Okay, this is the 2016, this is the current version. So, time, UT. Are you happy with the difference between universal time and GMT? Universal time is the mean solar time for the prime meridian obtained from direct astronomical observation and corrected for the effects of small movements of the Earth's relative axis of rotation. GMT is based on the hour angle of the mean sun, and for all tidal predictions may be taken as UT. It is quite confusing. We all learn zone time, whereas this is time zone. So if I asked you, UK is UT, isn't it? Ireland is UT. But if we look at France, now France is an hour ahead. Yet inside this book, it's going to say time zone -1. So let's have a look what it says you're meant to do with that, to do with time. In your actual exam, so far, they've always been on UT for the last couple of years. That's not to say it won't change, but it's generally on UT. They're trying to make sure you understand how to do tide, not your understanding of time. Just stay with me, I'll find the right. So this is zone time and time differences. Universal time is the mean solar time and time of the prime meridian, as I just said. There are 24 time zones in the world. 15 degrees around the world, 360 divided by 24 is 15 degrees, so every prime meridian is 15 degrees. That's an hour change. To convert zone time to GMT, the number of hours is given by the zone numbers added to or subtracted from the zone time. E.g. in zone -4, the time kept is 4 hours in advance of GMT. So France is zone time -1. Yeah, they are 1 hour ahead. See? Time zone -1. I know that feels like it's backwards. When you're working with these, you work in the time zone. Yeah, so when you're working with these, you work in the time zone of that. So you convert into the time zone of the tide tables. If it is time zone -1, that's UT +1. Yeah, you work at UT +1. So if it was 12 o'clock UT, then you would convert everything to time zone +1. Or zone time +1, but time zone -1. As I go through the app, we'll do a few examples together and I'll explain that better. It doesn't seem to cause a problem because it seems that all of the exams are in UT or in zone time -1 or UT +1. That's the only options they have from these. These are all Europeans. I can imagine it becoming more of an issue if they start using Pacific tides or if something changes. If it does, I will update this. Okay? As I said, I will work through it together with you inside the videos. Without much more ado, shall we do a secondary port calculation? So what I'm going to do is we'll do one which is a fairly standard exam. We're going to calculate the height of tide at Kinsale at 1900s, 1900 hours UT on the 27th of February. And there's a number there, 747. Now that relates to the secondary port number. I'm going to use the instructions for secondary ports from the back of the Admiralty Tide table. For a full explanation, do feel free to have a look at the book, ATT Tables, or I will put it inside the notes so that you can have a look at it. I'll also put it on the screen so you can see it alongside. First thing to do, as it says there, is use Fred's proforma. This is the same proforma as at the back of Admiralty Tide tables. So here it is here. We're going to find number 747. So 747 can sail. And the first thing I'm going to do is, for example here, I'm going to underline it. In your real exam, you're not allowed to mark these. On the front, it says, on no account must these tables be marked or defaced. Okay, I'm just going to do that so you can see which one I'm looking at each time. So the secondary port is can sail. Time is 27th of Feb. And we want to know the height at 1900 UT. Can sail, the standard port is COB, C-O-B-H. And the first thing we've got to do, let's have a quick look what it says. Go to the back here. Complete headings, enter high and water at the standard port. Okay, so the standard port is COB, so we find COB in the front of your Tide tables. It will give you a page, so it's saying, see page 26. Yep, so there's COB, page 27. It's a high water graph. I happen to have it here. There's the graph. And there is the time. So we're looking for the 27th of February. And we're looking for the afternoon tide. So high water was at 17:25. Low water was at 23:51. High water was 4.1 and low water is 0.4. That gives us a range of 4.1 less 0.4. 3.7. We have taken all the information we need now for the primary port. It then says to do your secondary seasonal change, sorry, not secondary. It then says to do a seasonal change. Seasonal change for the primary port. These seasonal changes, would you imagine there's going to be more water in the river or in the sea in the winter or the summer? UK. I'd imagine because of rainfall and bad weather, there'll be slightly more water in the winter. That is what it means by seasonal change. Now, this primary port here has already had the seasonal change applied to it, hasn't it? So we're going to remove the seasonal change if we need to. So COB is 751. You come down to the bottom of the page, or the next page, there'll be a column where it says seasonal changes. You're looking for the number 751, falls between 741 and 766. February, 0. So there is no seasonal change. That makes it easy for an example. Whew. We have a few later on that we can do together. So that's 4.1 and 0.4. Good. Next, we're going to work out the differences. So, can sail, and it has some differences. Now, these are differences. This has nothing to do with that section, what we are looking for at the end. This is the differences that we would apply depending on the time of high water, and then the differences for the high and low. So high water at 1725. People get confused with this bit, and I understand why. So I'm going to imagine some different numbers. Okay. And I'm going to say, so let's look at the numbers that we're going to use here. 1700, you had £20. Okay. So at 5 p.m. you had £20. You went to the pub and you were drinking solidly till 2300, and at which point you had £5 left. Okay, so at 5 o'clock you had £20. At 11 o'clock you had £5 left. How much money did you have in your wallet if you were drinking, constant drinking, at 2000 hours? Now you could work that out mathematically if it's a linear change, or you can do it with a graph. So let's do a graph to work that out. This graph is going to help us work out how much money we had at 8 o'clock. So the first thing we know is the range, the ends of the scale. Okay, so we start at 1700, and then every hour up until 11, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So that would be 20, 21, 22, 23. So that equates to 5 o'clock, and that equates to 11 o'clock. Then up this other scale here, we can do the change. So at 7 o'clock, we'll say we had, we'll go up in ones. So we say we had £0 there, and 1, 2, 2, 4. So that should be 2, 4, 6, 8, 9, 10, 12, 14, 16, 18, 20. So that's pounds. Yeah? How much money did we have at 5 p.m? We had £20. How much money did we have at 11 o'clock? We had £5. So it's there. So do you see what I've just done? That 2300 hours is tied in with £5, and 5 o'clock is tied in with £20. Now I could have drawn this in many ways. This is, for your yacht master, you did crocodile teeth. Now the crocodile teeth are perfectly good to do. There's nothing wrong with that. But crocodile teeth don't allow you to extrapolate. They only allow you to interpolate. That's okay, except for the fact that it says here, calculate differences, interpolate, stroke, extrapolate. So that means for time it's always going to be interpolate, but for differences for high and low water, you could be asked to extrapolate. We'll talk about the other one as well, actually, later on. This is something that people seem to do wrong across the board. It could be the difference between a pass and a fail. So maths will work perfectly well. It's a linear change. It's 3 buttons on the calculator. Happy for you to do it mathematically. I tend to not do it mathematically because the exam paper says show all working. And if I took the wrong day or the wrong time, or I made a clerical error, I would only lose 10% of the mark. But if I didn't show my working, the examiner can't give me marks if he wanted to. So I think it's best to use a system that shows the examiner that you know how to do it. And also, it makes sense, I would think, to do the way that they suggest that you do it in the piece of paper that's in the exam. So they're showing it, it's hard to see it in this version. I'm sure it's hard to see it in your version, but they're actually showing you using it graphically. So we'll go back to it. At 5 o'clock we had £20, so that's tied into that cross there. And at 11 o'clock we had £5, and that's that one. So that allows us to draw a line. Yeah. And to interpolate, we only draw in between those, we don't go beyond. We could extrapolate that at midnight we have £2. Or we can interpolate for 8 o'clock. So for 8 o'clock, how much money did we have? We go straight up. And then we go across. So we had £12. If we carried on drinking, if we looked in our wallet at 8 o'clock, we'd have had £12. Just about enough for 2 gin and tonic. Or 3 pints. Yeah, 3 fours. Cheap pints somewhere on this country. Does that make sense? Are you happy with that? So let's do the example here for Kinsale. So, Kinsale, we are looking for 1725. That is between 1700 and 2300, isn't it? So we write down our outer limit, 1700. And if it was 1700, it would be minus 19 minutes. If it was 2300, it would be minus 0.005 minutes. How much is it at 1725? So it's exactly the same concept of at 5 o'clock we had £19, at 11 o'clock we had £5. How much money did we have, or what's the difference, or what's the rate change at 1725? So we'll do it exactly the same way. We'll call this 1700. 4. Now it doesn't matter what scale you use, the bigger the scale, the more accurate you will be. So that's 18, 19, 20, 21, 22, 23. And we're going from 19 to 5, so I'm quite happy to go from 20 again, so that's 20 minutes. So we're going to 5, so let's go 2s again. So that's 18, 16, 14, 12, so at 1700 it's 19, so it's there. At 2300 it is 5. So that gives us a rate change of that. Yeah, happy? We wanted to know what it was at 1725. So that's 1730 there, so it's about there. So that's going to be 18 minutes. That's minus 18 minutes. Yeah. minus 0018. So that means that high water is going to occur 18 minutes after at the secondary port. Low water, let's do a low water one. Low water difference then. So low water is 2351. So Kinsale 2351 falls between 2300 and 0500. If it was 2300, the correction would be minus 0023. If it was 0500, the correction would be minus 009. So if the low water time was 11 o'clock, it would be just a correction of minus 23 minutes. If it was at 5 o'clock, it would be a correction of minus 9 minutes. How much is the correction at 2351? Draw another graph. Come down. Now it doesn't really matter which way you have the scale or which way it works. I seem to tend to always put time on the bottom and then difference on the side. I'm going to start at 23. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. So that will be 0, 0, 01, 02, 03, 05. And we're going from minus 23 to minus 9. So let's go from minus 10 to minus 25. So minus 10, go up in twos. You can have graph paper, by the way, in the exam. There's no reason why you can't have graph paper. If the school won't supply it to you, you can take your own in. So 12. Nope. 28. So at 2300, yeah, 11 o'clock, the correction would have been minus 23. So that's there. At 0500, the correction would have been 9. So let's find 9. Would have been here. Yeah? So and we're looking for 2351. I'm sorry, I have to go back. Yeah, from that line there. 2351, 30, 15, so it's 45. Be about there. So the correction value there would be minus 21. Which makes sense, doesn't it? 2300 is minus 23, going towards minus 9. Yeah. Next we have to work out height differences. So let's have a quick look and see what we've got. We have 4.1. Kinsale. If it was 4.2, yeah, so it's 4.2 at the top there, and if it was 4.2, the correction would be minus 0.1. If it was 3.3, it would be minus 0.1. So if you think about what we just did there with the graph, that means that 3.3 and 4.2 is all minus 0.1. It's a straight line. What's it going to be then at 4.1? It is going to be minus 0.1. That's nice and easy, that one. Low water, if it was 1.4, yeah, the correction would be plus 0.1. If it was 0.5, the correction would be 0. See what I'm doing here? These are the times of the high water and the low water. Times are low and high, differences of height. So if it was nearer 1.4, the correction would be plus 0.1. If it's nearer 0.5, the correction would be 0. We have 0.4, which means that you actually have to extrapolate. You have to go beyond. Here, it's going to be 0. We'll do a few, especially around Greenock, where you actually have to extrapolate quite a long way outside of the range. I'll talk about extrapolation soon. 4.1 minus 0.1 is 4.0, 0.4. Is there a seasonal change? So Kinsale is 747. In February, no, so 0. Means that we have 4.0, 0.4. Secondary port is, do it with the calculator, if you have it, let's not waste our marks. 25 less 18 equals 7, so 1707. And 51 less 21 is 30, 2330. So, what does this mean? This means at Kinsale, high water will happen at 1707 and it will be 4 meters. Low water will happen at 2330 and it will be 0.4 meters. We need to work out the height of tide at Kinsale. So we go to the primary port and we use the tidal bell diagram, the tidal diagram. So in your exam, you'll go into the tide tables and you would find the tidal diagram that goes with that, so page 26. Yeah, and you would have to use that one. They'll give you a sheet, they don't want you to write on there, on their exam forms, so they will give you a sheet, be in the exam. And you fill in the secondary ports information into here. So that means high water is at 1707. We've got high water of 4, low water of 0.4, draw a line between the two. And we wanted to know at 7 o'clock. So that's 1807, 1907. So that is 1907 there. They're 10-minute blobs, so that's 1810, so that's going back. So about there is 1900. You take that up. And you take it up. You have to decide, is it springs or neaps? We have 3.7, which means it's beyond springs, but you do not extrapolate for this bit. I'll just very quickly show you. So we're trying to find a height at a given time. So on the appropriate standard port curve diagram, plot heights of high water and low water. So we've just done, isn't it? High water and low water. Enter the high water time and sufficient others to embrace the time required. From the required time, proceed vertically to the curves using range at standard port. So we wrote that one down there, 3.7. To interpolate between springs and neaps, do not extrapolate. Proceed horizontally to sloping line and then vertically to height scale. So we go up to the appropriate curve, either springs or neaps. then I do suggest using your parallel rules because you can work it up quite neatly. Take that across, where it cuts across. So I read there as 3.1, 3.15. So we'll call that 3.2 meters. Yeah. Therefore, the height of tide at Kinsale is 3.2 meters at 1900 UTC on the 27th of February. Happy? So, we've finished doing our first second report together. In reality, in the exam, that'll be the question. They're going to say, what time can you go over a bar? Or they're going to say your vessel draws 3 meters, you have chart datum of 1 meter of water. What is the height of tide at 7 p.m.? Or what is the tidal window, or something along those lines. I've given you 10 worked examples inside the app. They will help you. Yeah, I have given you the hardest one I can come up with the data. I've given you very similar ones that have been past papers. If you can do my 10, you will be very well placed, along with the radar plotting and the chart work. Looking at the syllabus again, states difference in calculation of Pacific tides, including secondary ports. So it's all about semi and diurnal tides. So we have a diurnal tide in the Pacific, we have a semi-diurnal in the UK, and you can get a mixed tide. So in the Atlantic, they're normally semi-diurnal. That means they occur twice daily. In the Pacific, there are many instances of diurnal, so it's just one high and one low. There is a set of tide tables that could be used for the Pacific, and I've given you an example of that inside the notes. You can see it there. It really wouldn't make any difference to the way the exam is worded, but we have at least covered the syllabus.